Hi friends, welcome to I-Smart Champs. Today our topic of discussion is 12th Mathematics Determinants. So in this topic what I'm going to discuss is actually the previous year questions with some concepts. First, initially I'll give concepts, how to solve the determinant. Very basic problems today we'll solve in the lecture 1, and later very simple problems and few challenging problems. I'll solve. So here, and I'll discuss a few properties, one or two properties, and some few formulas of the determinants on this topic. So by the way, in order to understand determinants, you need to know what is a matrix first of all, and assuming that the student knows matrices, I am starting this one. This is my first video on 12th mathematics was integrals. This is my second video on determinants, and some more videos I have posted which are connected to 12th chemistry as well. 12th chemistry I have posted 12th chemistry syllabus at a glance, you can see in the videos. And so in the 12th chemistry I am discussing a question paper. I have taken about 65 questions overall for the overall syllabus, and the 65 questions with instant answers I have discussed in that video. So within 1 hour you can see that video, and please do subscribe my channel, and the subscribe button is available over there. And now let's move on to the topic determinants. So by the way, what is a determinant? Determinants. You can put up the heading determinants. And then what's a determinant is, for determinants, they are meant for only for square matrices. Square matrix. Determinant is actually a number associated with a square matrix. You can make a notes out of this one. So determinants exist only for square matrices, and it's a number associated with a square matrix. And what is the use of determinant? Determinants are being used in coordinate geometry, physics, and physics, especially vectors. We have tremendous applications of these determinants, where you would have seen in the vectors like the cross product of vectors, A bar cross B bar, and your first year physics, and like calculation of torque, when the R bar and F bar are given to you, you might have calculated R cross F. And of course there are several other things, and volume of parallelepiped, that is 3D geometry. We are going to see those things, 3D geometry, okay, volume of parallelepiped, area of the triangle, calculation of the area of the triangle, and so on. We have many applications of this determinants. Okay, so determinant is a number associated with a square matrix. For now, this one. And in this, for your syllabus, what we are going to discuss is a 2 by 2 and 3 by 3 determinants. 2 by 2 determinants and 3 by 3 determinants are the things what we are going to discuss. Let's start with a 2 by 2 determinant. So how to represent a determinant, all these things I'll teach you now. So how to represent a determinant. So like suppose there is a matrix like A, B, C, D. A, B, C, D, you know this 2 rows are present and 2 columns are present. So it's a 2 by 2 matrix, 2 rows and 2 columns. And the determinant of A, that is called det A. Det A will represent it like 2 bars like this, and then write the elements of the matrix as it is, A, B, C, D. And for a 2 by 2 determinant, the number is calculated like this, AD minus BC. So the formula for this is AD minus BC. Like this, using this simple formula, we can calculate the determinant of the matrix, and the number what we get is the number associated with the matrix, and that's called determinant, the value what we get out of this. Okay, let's start with a small example how to calculate the determinant of a 2 by 2 matrix. So the first one, what I'm going to tell is that let us take an example. A is equal to 1, 3, 7 and 15, let us say. So I want to calculate det A. So how to calculate det A? So like this we'll write 1, 3, 7, 15, and as I said, AD minus BC, like this will do. So that is 1 into 15, which is 1 into 15, I'll write in steps, minus 7 times 3. So that is 15 minus 7 3 is 21. 15 minus 21 is minus 6. So this is how one can calculate the determinant. So the next one, let's move on to the next one. So I'll give you some time to write, so please note it. So this is the one how we calculate, this is how we calculate the determinant. The next one is what we will see is that in order to understand determinants, there are one more thing I want to tell is a singular matrix. What is a singular matrix? What is a singular matrix? A singular matrix is a matrix where the det of that matrix goes to 0. The determinant of the matrix, we should not read it as mod, we should read it as det. Det A goes to 0. If the determinant goes to 0, we'll call it as a singular matrix. So for example, A is equal to, let's consider like 11 and, okay, 11, 12, I'll give 12 11s, very simple so that you will understand this one. So let's see this matrix 11, 12, 11, 12, like this we have taken a matrix. And now let's calculate what is det A. Det A happens to be 11 into 12 minus 11 into 12. So the value of the det goes to 0. So this is a very simple example where the determinant goes to 0. Okay, let's take another example so that you will understand better. So I'll consider another matrix. A is equal to like 8, 18, 9, 16. This is another matrix which is given to you. So when I ask you to find what is the determinant of A, det A happens to be 8 times 18 minus 9 times 16. So 8 times 18 is 144, 9 times 16 is 144, and the det value goes to 0. So this is an example of the determinant where the det value goes to 0. If the det value goes to 0, we'll call it as a singular matrix. If the value of the determinant goes to 0, then we'll call it as a singular matrix. Okay, please, I'll give you some time to note. You will note it. Okay, hopefully you would have noted. Yeah, next let's see what is a non-singular matrix. If we know the singular matrix is the case where the determinant of A goes to 0. The non-singular matrix is a case where the det A is non-zero. So we have solved both things. The case where the determinant of A goes to 0, that's called a singular matrix, and det A is non-zero, it's a non-singular matrix. Pretty straightforward thing. After this, we have some few properties I'll discuss on these determinants. Det of A transpose. If you take the transpose of the matrix and then take the det, that is equal to det of A. This is one property. And this another property. Let's see other properties. So we have, suppose our matrix A is a n by n square matrix, assume. So if I write Ka, that means K times, K is a scalar, scalar refers to K is a scalar, K is a scalar, and scalar refers to a number which is a real number, and non-zero real number we consider a non-zero real number. If we multiply with the matrix, then K should multiply all the elements of A. For example, if I consider a matrix like 1, 3, 5, 7, if I ask you to find what is 3A, that means 3 should be multiplied with every element of A. That means 3 1s 3, 3 3 is 9, 3 5 is 15, 3 7 is 21. So this is how you got to find the 3A. So in fact, K refers to, if A is an n by n matrix, K will multiply all the elements of the matrix, present. So for if you consider a 2 by 2 matrix, it happens to be multiplying all the 4 elements. It is 2 by 2 refers to 4 elements you will get. N by n refers to n square elements will be there, and these n square elements have to be multiplied by this K. So that's the idea what you need to get. And then the K will be multiplied in all the rows you can take, or all the column that you can assume in the whatever the way you like. So here 3 is multiplied to this row as well as this row. That's what you have to understand. In case of determinants, how to consider this one in case of determinants? Okay, for the matrix, if you consider multiplying a matrix with a scalar refers to this one, multiplying every element. But in the case of determinants, K times det A refers to the K should be multiplied either only for K should be multiplied, I'll write fully, K should be multiplied only for a row of your choice, or a column of your choice. You can multiply to either only for a row or only for one column, actually only for one column or one row. Only for one column or one row you can multiply. This K should be multiplied as per your choice, as per the convenience. You can multiply this K to the determinant, which means that if you have a row like this, if you have a situation of this sort, like 3, 6, 1, 7, suppose they ask you to find the det, I can take 3 common out of these 2 elements out. So if I take 3 out as common, that is 1, 2, 1, 7. This is how I can write the det. And 3 can be multiplied to this column itself. So if I multiply this to the column, so that is 3, 3, to 7. The beauty is that the value of this one as well as this one are same. You can calculate it. See, 3 7s 21, and then 21 minus 6, that's 15. You can see 7 3 is 21, 21 minus 6 again 15. So either of the way we are getting the same value. So you see, that's the variation. 3 is taken out of the row and multiplied to this column right now. This is what I did. So this you have to observe. K should be multiplied either only for a row, or only just one row you have to multiply, or only for one column of your choice. This is very, very important. So K can be taken out as common from a given row or a given column if the K is the GCD of that particular elements of the given row. So this is the idea what you need to get. So let's move on to the other one. Please note it. Let's move on to the other one. So based on the concept what I have discussed, I wish to solve some few questions based on the concept what I have discussed with you up to now. So let's move on to some questions. These are previous years. These are the questions which are obtained, which I got from previous years. So the first one is All India 2009. All India 2009 compartment. This question was asked. So we got to evaluate the value of debt √6, √5, √20, √24, √20 and square root of 24. This is what the debt is being asked. You can expand this debt straight away, or I will tell you the my method will teach you the how to practice the removing the GCD out of the row or column. Now the thing is that when we can do it this straight also, √6 into √24, √20 into √5. So square root of 6 times 24 is what we have, minus square root of 5 times 20. This is what we have. So you can see that that is square root of 6 times 24 is square root of 6 times 24 is 6 times 4 we can write, and then 5 times 20 we know that's very much, it's 10 square, that's 100. So I'm writing this straight away. So that is 6 times 2 minus 10, so that's 12 minus 10, that is 2. This is straightforward, pretty straightforward question. You can answer like this. There is another way. By understanding the properties of the determinant also we can solve. How that can be done? So hopefully you have noted this one to now. I'll solve this one here. So you have √6, √5, √20 we can write it as 4 times 5, and square root of 24 is 6 times 4. You can see √4 is common. √4 is nothing but 2. So 2 can be taken out of the determinant. So that is 2 times √6, √5, and here √5 and √6 over here. So I'm taking √4. √4 is nothing but 2. So √6 times 2 I can write here. Here I can write it as 2 times √5. 2 is the GCD of this entire row. 2 I am taking out as common here. So you got this, and now you can evaluate the debt as 2 into √6 into √6 is √6 whole square, minus √5 into √5 is √5 whole square. So this is 6 minus 5, which is 1. So 2 is the one. 2 times 1, that is 2. So either of the way you can get the same answer. And let's move on to another question. Hopefully you understood how to take 2 out of common, and then take a note of this one. Let's move on to the next question. So noted. Okay, we'll go ahead. The next question follows. Find x from the equation. So this is asked in All India 2009. All India 2009 this is asked. I am discussing previous year questions to you. So we got to find the value of x if this date is 0. So x4, 2, 2x, 2, 2x. See, the x is not present in the same row or same column, but you can see 2 is present here, and then you can take it to 0. 2 is present in this row, and here for this column also 2 can come out as GCD. So you can take out 2 times. So this is x 4 1 x once again, so that goes to 0. So 2 is a non-zero number which can be sent to the other side, that makes it a 0. And now what is left is 2 times x square, x into x is x square, AD minus BC I am doing. So x square minus 4, that goes to 0. 2 can be sent to the other side, x square is equal to 4, you can make x is equal to plus or minus square root of 4. Always remember, root of a square is modulus of a. Please remember this one. And x is equal to plus or minus root 4, x is equal to plus or minus 2. Hence the answer. So let's move on. Always root of a number will generate only positive value. This is what you have to understand. Square root of a number will generate positive value. Don't write root 4 as plus or minus 2. It's plus or minus x is equal to plus or minus root 4. Plus or minus root 4 will generate plus or minus 2. Root 4 will generate, root 4 value is always 2. So this is what you have to remember. Don't write plus or minus 2. It's wrong to write plus or minus 2, which I want to tell you. Okay. So let's move on to the next question. I will discuss on this topic separately, why it is so. So let's move on to, this is the common mistake people will commit, and then please understand this is how to write the answers. Let's move on to the next question. So what is the value of x? Next question. What is the value of x for which 2x3, 5x. You got to find the value of x for which these two determinants are equal. 16, 3, 5, 2. What is the value of x for which these two determinants are equal? So for this, what we have to do is, let's evaluate the determinant here. 2x into x is 2x square, 5 times 3 is 15, AD minus BC, 16 2 is 32, minus 5 3 is 15. So this is what we have. 15 can be cancelled on either side. Don't subtract the things. 15 and 15 can be cancelled on either side. And then you have 2x square is equal to 32. So x square happens to be 16 for us. X square is equal to 16. Again, x is equal to plus or minus root 16. The root 16 will deliver only 4. So that value is plus or minus 4. Hence the answer. Let's move on to the next question. So please note it. Let's move on to the next question. Note it? Okay. Our next question is if this is foreign 2011 question. This is asked in foreign 2011 and also asked in All India 2009. this particular question what I am discussing is asked in here. So it's given that if these two dates x 1x is equal to 3412, what is the value of x? So it's said very easy, x into x is x square minus 1 into x is x, that is equal to 326 minus 4, that is 2. So we have a quadratic, x square minus x minus 2 is equal to 0. The quadratic can be solved so easily, and they asked, what they asked is positive value of x positive value only, they want the positive value of x. So x square we can write it as minus 2x plus x minus 2 is equal to 0. So x into x minus 2 plus 1 into x minus 2. So you have x plus 1 into x minus 2, which goes to 0. So x plus 1 is equal to 0. We have two things, x minus 2 is equal to 0. So this generates, the first one generates x equal to minus 1. So we should not take this because positive value of x is what we want. So x is equal to 2 is the required value we need to report. So this is how we have to solve the problem. So please note, let's move on to another question which is little bit challenging, Okay, let's move on to the next one. So the next question is All India 2011. This particular question what I am discussing is done in All India 2011. And the question is date of cos 15, sin 15, sin 75, cos 75, sin 75 and cos 75 degrees. This is what the question is. Now we got to find the value of this determinant. Now let's understand this. So let's expand this one. So AD, that is cos 15 cos 75 minus sin 15 sin 75 degrees. So when you expand this one, this is of the form cos A cos B minus sin A sin B, which is cos of A plus B cos of 15 plus 75. So cos of 15 plus 75 is cos 90 degrees. Cos 90 value is 0. You can see this determinant is an example of a singular matrix. This determinant is an example of a singular matrix. You can see this. So hopefully you have noted all the questions. Okay, let's move on to the next question. Yeah, let's see. I'm giving now a set of 6 questions to you as homework for you. Find the value of x if the following matrices are singular. And this is the first matrix. A is equal to 5 minus x, x plus 1, 2, 4. You have to find AD minus BC and set it to 0. That is, det A you have to set it to 0. You will get the answer 3. And like this, you can see the second one. You can note it, Delhi 2011 it is asked, and this is Delhi 2011, that is Delhi 2011C. The answers also I have provided over here. You can pause the video and make the note of these questions and give a try. And after this I will discuss a challenging problem based on setting the det to 0, that whether the matrix is singular or not. There is one challenging question for us. So that also I will discuss after this. Please make a note. Hopefully you would have noted. So let's move on to the question. Okay. Shall I clear this? Okay, I think I'll wait for some time, and then I think I can clear. So I'll clear this one off and then start a fresh question. Yeah, this is the challenging question I wish to discuss with you right now. And the interval pi by 2 less than x less than pi, find the value of x for which the matrix 2 sin x 3 1 2 sin x is singular. They said this matrix is singular, which means det we have to set it to 0. But please understand this condition, pi by 2 less than x less than pi, which means that the x belongs to second quadrant. From the basics of trigonometry, we know very well that sin x is positive in the second quadrant. So while expanding the determinant and setting the determinant to 0, the value of sin x what we obtain should be positive. This is the idea what we need to keep in mind. So you have 2 sin x 3 1 2 sin x. We need to set the det to 0. So after this what we get is 4 sin square x, that is 2 sin x into 2 sin x is 4 sin square x, 1 into 3 is 3 is equal to 0. So I got the scenario where sin square x is 3 by 4. So sin x we need to consider the positive value, that is root over 3 by 4, because sin x is positive in the second quadrant. So all symmetric cups, you know this very well. So sin x is positive in the second quadrant. So the value of sin x would be root 3 by 2. We need to consider only the positive value, and we have to find the x value where sin x is 3 by 2. So x is 2 pi by 3. So that is 120 degrees in terms of degrees. X is equal to 2 pi by 3 will be the answer for this question. And 2 pi by 3 belongs to pi by 2 less than x less than pi, that it belongs to second quadrant, that is 120 degrees. Hence the answer. So you should not write the negative value of sin x because sin x is positive here. So that is the reason this question is challenging. People may write sin x is equal to root plus or minus square root of 3 by 4, which is absolutely wrong, because x belongs to second quadrant, sin x is positive. So this is the idea. Please note it. So let's move on to the next question. I'll rub this off. So let's move on to the next question. These are the questions based on the 2 by 2 matrices where the given matrix is singular. So there are other type of questions, another model type what I see over here, or this is find x. You have to find the value of x where the two dets are equal. That means if they have given, if det of x plus 1, x minus 1, x plus 1, x minus 1, x minus 3, x plus 2, x minus 3, x plus 2 is equal to 4 minus 1, 1, 3. 4 minus 1, 1, 3. So this is the det what is given. We have to find the value of x for which these two determinants are equal. So what we do is we'll expand these dets separately and then find the value of x. This is what we'll do. So here let's solve this. X plus 1 into x plus 2, that is AD, minus BC, that is x minus 1 into x minus 3, which is equal to 4 3 is 12, minus 1 into minus 1 is minus 1, so that's plus 1, so that's 13 for us. So x plus 1 into x plus 2 is what we have to find. That is x square, x into x is x square, plus 2x plus x plus 2 minus of x square minus 3x minus x plus 3. So when we expand, this is what we get. So again, we'll take the negative sign. X square plus 2x plus x is 3x plus 2 minus of x square 3x, that is minus 4x. So plus here and minus 3, that is equal to 13 over there. So x square is gone. So 4x plus 3x is 7x, and 2 minus 3 is minus 1. So minus 1 is sent on other side. 7x is equal to 14, x is equal to plus 2. So that's the answer. So please note it. Let's move on to another question. Please note it. So let's see the next questions. This is Delhi 2014 compartment. So they asked to expand this date. So that is p square minus of p square minus 1. That is p plus 1 into p minus 1. That is p square minus 1. So you have p square minus p square plus 1. P square 1. So the answer is 1. So let's see this question. So this is again the equating two dates type question, and we have to find the value of x. 3x into 4, that is 12x, minus 2 into 7, that is minus 14, minus of minus 14, which is equal to 8 4s 32 minus 6 7s 42. So here we have 12x, minus of minus is plus, plus 14 is equal to 32 minus 42, which is minus 10. So 12x is equal to 14 when it's sent to the other side, minus 10 minus 14, that is minus 24 for us. So the value of x is minus 24 divided by 12, that is minus 2 for us. So in this particular lecture, what I am discussing is only 2 by 2 determinants and different questions which are asked in previous years on this 2 by 2 determinants. That's the idea here. So later I will present you how to solve the 3 by 3 determinants, as well as previous year board examination questions, how they have come. And later, after the board examination questions, I will also present you the IIT JEE as well as BITSAT questions pertaining to determinants. So that's how the lecture goes. This is the next question will be the last question of the video. So in order to solve that question, we need to know one simple small funda. The funda is that if A and B are two square matrices, det of AB is det A times det B. This is one very good property. Based on this, the next question is given. They have given a matrix E. What is the matrix? We'll see. The matrix A is 1 2 3 minus 1, 1 2 3 minus 1, and the matrix B is given as 1 3 minus 1 1, 1 3 minus 1 1, and find det AB. This is what they have asked us. See, the natural tendency is that we'll multiply these two matrices and then we'll try to solve the det. But if you do that, you will lose time. So what we do here is find det A and det B individually and then multiply those two. So the det A is 1 2 3 minus 1 and det B is 1 3 minus 1 1. So if we take the products, so 1 into minus 1 is minus 1, 3 into 2 is 6, so that's minus 6. Here 1 into 1 is 1, and then minus 1 into 3 is minus 3, so that's 1 plus 3 for us. So the value is minus 7 times 4, so the value is minus 28. Hence the answers. So that's it for this video. If you like the video, please subscribe and please give a comment. And then in the next lecture, I will present how to solve the 3x3 determinants, cofactors, minors. All those things will come in the next lecture. These are the previous year questions, and this question especially was asked in Delhi 2015 C. So this was asked in Delhi 2015 C. This question was asked at that time. So these are the answers for us. So end of the lecture 1 on determinants. So in the next lecture, I'll teach you how to solve the cofactors and minors, and how to handle a 3x3 determinant, and what are the properties of 3x3 determinants, and few things, how to apply row and column transformations. Those things I will discuss in the next video. So do your best efforts. Thank you very much.